Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Pekar. This is Unit 7 Notes Video 1. We're going to break it up into two parts so you can take your time in both parts of this notes video. So the first one, we're just going to do the front page of the notes. The second notes video will be the back page of the notes. And what we're going to be able to do in both these videos is I can graph polynomial functions and locate their real zeros, maximums, and minimums. And also we're going to talk about end behaviors again. So this first problem we're going to look here, real world problem. The percent of the United States population that was foreign born since 1900 can be modified by the P of t function. You can see right there. Where t equals 0 is 1900. So when you get to t equals 10, that will be 1910. You're just adding 10 on to 1900. Notice that the graph is decreasing. Well, let's look at the graph. Notice that the graph is decreasing from t equals 5 to t equals 75, and then it begins to increase. The points t equals 5 and t equals 75 are what we call turning points in the graph. Yes, right here, t equals 5, that's 1905 actually. The graph starts to progress down, and when it gets to t equals 75 right there, it starts going up. It's a turning point. If this graph would continue before 1900 here, it probably looks something like this. This has two turning points, so that leads me to the degree, a little bit of this graph. Okay, the degree of this graph should be odd. It looks like my end behavior here is going up, and my end behavior here is going down. They're going in opposite directions. That means it has to be an odd degree. Couple ways you can find degree is you can count the number of turning points. Here, this is what we call a relative maximum. That's one turning point. And right here, we have a relative minimum. It's the lowest point of the graph in that area. This is the highest point of the graph in this particular area. Those are called turning points. You take the number of turning points and add 1 to them. So we have 2 turning points plus the 1. This would be a degree of 3, and that is odd. And that makes sense because the end behaviors are going in opposite directions. Another way to do it is start at one of the behaviors and count the directions that you're going in. Here I'm going up, that's one direction, and if I keep going around it, now I'm going down, that's 2 directions. And if I keep going, here I'm going up, that's 3 different directions, so that's another way to count degrees. So this would be a degree of 3 for this particular graph. But the turning points are one of the things we're going to be talking about. Real zeros of a function. The x values where a function crosses the x-axis, that's where y is equal to 0. These are called real zeros of a function. So just making up a little graph here, I'll do a degree of 3 again. Real zeros are where it crosses the x-axis. So like, there's one real 0, there's another real 0, and there's a third real 0. So this particular graph would have 3 real zeros. Looking at a little bit different graph to talk about real zeros, and this is a degree of 3, so it should have 3 real zeros, but sometimes it doesn't always work out that way. This particular graph is even. Both my end behaviors are both going down, so that means it's going to be even. If you follow the graph, I'm going up 1, down 2, up 3, down 4. This would have a degree of 4, but it only has 1, 2 real zeros where it crosses the x-axis. That's what we're looking for, is those points where it crosses the x-axis for real zeros. Okay, so that's that. Let's talk about relative minimums and relative maximums. Now here we already looked at these a little bit, relative minimums and maximums. These are called our turning points in the graph, where it changes from going up to down or from going down to up. A relative maximum, a point where the graph changes from increasing to decreasing. No other points around it are higher. So, trying to give you an example of that, I guess. We'll look at a graph again. I'll go with a degree of 3 again. Something like this. A relative maximum, a point where the graph changes from increasing to decreasing. So we're increasing here, now we're decreasing. this point right here is what we would call our relative maximum. There's no other points around it that are higher. You can have more than one relative maximum and more than one relative minimum for that matter, but let's look at a relative minimum, point where the graph changes from decreasing to increasing. So I guess right here we're decreasing and then we're going to increasing. This point right here would be considered our relative minimum. Look at a couple. I'll do another graph here. This is an even one. Both my indicators are going down. I have one relative minimum right here, but here, this point and this point right here, we would have relative maximum. So you can have more than one relative maximum, even if they weren't the same height or anything. This is increasing to decreasing, so that's relative maximum. This is increasing to decreasing, also relative maximum. So, and these are called turning points in the graph. What else do we have here? Oh, let's actually graph one now. This is number 1. It's the last thing we're going to go over for this particular video. There's a lot going on, so I'll try and explain it the best I can. The graph the polynomial function f of x equals x cubed plus x squared minus 4x minus 4. Given that x equals -2, right here is one of our zeros. That means it crosses the x-axis at -2. Find the other real zeros, find the relative maximums, relative minimums, and describe the end behaviors. Okay, so first thing I'm going to do is this. Zeros. They already give us one of the zeros. They say we have a 0 at x equals -2. Okay? Being it's a degree of 3, x cubed here, we probably should have 2 more. Sometimes there isn't, but we'll look at the graph and decide that. So we need to break this function here down so we can find the other 2 zeros. And we're going to do that by using synthetic division. I know x equals -2. It told us that right here. That's one of our zeros. So using synthetic division, I'm going to put that in the box first. That would come from the factor x plus 2 equals 0. If you solve that, you get x equals -2. We've already solved for x. X is -2, so that's why we're putting that number in the box. And list out our coefficients and constants. 1x cubed, so I'm going to put a 1 here, plus 1x squared, so I put another 1, minus 4x, and minus 4. And this is in degree of decreasing order, so I don't have to add any zeros in here. So let's break it down. First number we always bring down, that's 1, and then we start multiplying. 2 times, or -2 times 1 is -2. 1 plus -2 is -1. The -2 again here, times -1 is +2. You always add the columns. -4 plus 2 is -2. -2 times -2 is +4. That's good. That adds up to 0. That's my remainder. Okay, so it's saying it divides in there evenly. Okay, so we got to do a little bit of work here. We were dividing into an x cubed term, so this first 1 right here is actually 1x squared, 1 degree less, minus x, and then minus 2. If I divided by x plus 2, this is what I would end up with, x squared minus x minus 2. And to find our other 2 zeros, we would just factor this quadratic, set them equal to 0 and solve, and that would be our other 2 zeros. So factoring this, it's just a general trinomial. There's no greatest common factor that I can factor out. So first of all, breaking the x squared down, that's x and x. I need factors of -2 that add up to -1 right here. And that's going to be -2 and +1. You can check your work. I know that -2 times 1 is going to give me my -2 right here. But it's the outside product, which is x times 1 or 1x. And the inside product, -2 times x is -2x. That has to add up to -1, and it does. -2 plus 1 is equal to -1. So this is factored correctly. Anyway, so what are my other zeros? Well, first of all, I'm going to take x minus 2 equals 0 and solve that by adding 2 to both sides. X equals 2. So that's another 0. Set the x plus 1 equal to 0. You're going to subtract -1 from both sides, so -1. So my other two zeros are 2 and -1. So I can go back up here now and say x equals 2 and x equals -1. So those are my three zeros. So graphing this, we're going to use our graphing calculator in a little bit, but we can graph a few points right away. X equals -2, x equals +2, and also x equals -1. Now we have this table here, and we could use this table to find some other points, but I want to show you a little trick. We have f of x equals that positive x cubed plus the x squared minus the 4x minus 4. This x cubed, this leading term, the first term, kind of decides your end behaviors. Number one, it's a degree of 3, so it's odd. So my end behaviors are going to go in opposite directions. So it would look something like this, or it would look something like this. So which one is it? Well, being it's positive x cubed, what that means is as x approaches positive infinity, that's this side of my graph over here, going positive, the right-hand side. F of x has to be positive also because it's positive 1x cubed here. So I could say it's going to come down something like this. My end behavior on this side is going to be positive, and then it just kind of snakes through these points, and it should come down negative on the other side. So it roughly could look something like this. And if you had a graph like this, that would be perfect. I would take that. We're going to get a little bit more precise here in a second. But if this was -1 x cubed, that means as x approaches positive infinity over here, then it would have to be negative and look something like this. Now it is not -1x cubed. We have the f of x, and our leading term is x cubed, so that means it's going to be positive as x gets positive. So we're going to go with this right here, okay? And you can say, hey, that's my graph. That's a pretty good job. You can estimate your maximums and minimums. Here we're going to have a relative max right here. We're going to have a relative min right here. But I'm going to use the graphing calculator to kind of figure out these points a little bit more precisely. So, and I'm going to show you how to do that right now. So, first thing I would do is you got a table here. I know when x is equal to -1, y is 0. I know when x is equal to -2, y is 0. And I know when x is equal to +2, y is 0. I get some more points in here, I can kind of figure out how this graph is laying out a little bit more precisely. So y equals, and I'm going to clear that out, and we're going to type in the function that we're given here. It starts out x cubed, so I'm going to hit x variable, caret key, and then 3. Just arrow over to get back down. Plus x variable, caret key 2, so x squared. And then minus 4x, and finally minus 4. Let's see if I got that right. I got it right. I'm going to hit enter, and then we're going to graph this, and you can come up with the table and kind of figure things out from there. But I'm going to go to zoom, and then go down to zoom standard. This will give you a nice 10 by 10 screen. Oops. Let's get back up here. Could just hit 6, but I'm going to hit enter. And there it is, 10 by 10, and the graph should be coming in. You can see it goes through our zeros. It goes down a little bit farther for our relative maximum. Our relative minimum, our relative maximum is about right. So to find these points, these relative maximums and minimums, because we kind of do have to find that, we're going to go to calculate. That's second and then trace. So I'm going to find our relative minimum first. Enter. Here's how you do it. You got your cursor here, and it says left bound. If you look over on the calculator on the left-hand bottom corner there, it says left bound. You want to be on the left-hand side of that relative minimum, and just hit enter. Now it says right bound. So you have to get on the right-hand side. I could be right about here, that's fine. I just go up a little bit, whatever, and hit enter. So it's going to find a minimum in between these 2 points. I think I was looking for minimum. We're going to find out in a minute here. Hit enter again. And the minimum is at y equals negative 6.6. Yeah, that's right. Or you could just say negative 6. Close enough. And it's about 0.886 or 0.9, whatever. So I'm going to go over here and say my minimum is about negative 6. That's for the y value. And it's about 0.9, or you could even say 1 if you want to. It's pretty close to 1 for our relative minimum. Now, to find our maximum, we kind of do the same thing. So first I'm going to graph that in there so we can look at that. Negative 6. 1, 2, 3, 4, 5, 6. It was right in here somewhere. So our graph actually came down a little something like that and then went up. And now we're going to kind of look at our maximum, relative maximum. So second and then calculate again. Let's go down right there. Same thing, you got to get your cursor on the left-hand side where it says left bound. You got to get it on the left-hand side, so just arrow key over there. That's about where our maximum is at. I'm guessing it's going to be about 0.8786, something like that. You can do it that way too, actually. This will give you pretty close to the exact. I'm going to hit enter because I'm on the left-hand side. You can see those dotted lines. It's going to find, whoops, a little too far. Hit for right bound, you want to be on the right-hand side, hit enter. And then it says guess. Well, it's not really guessing. It's going to tell you pretty much what your maximum is. 8.7, 0.87, 0.88. That's pretty good. And that's at negative 1.535. I'd say negative 1.5 is close enough. So at, that's the x, negative 1.5. And it's about 0.88, or you could say 0.9, whatever. That's our maximum. So a couple turning points here. I guess it'd be right about here. So we're going to go up and then go down. So the red was our estimated graph. The blue is a little bit closer to what our actual graph is. You could go into table second. Actually, let's go to table set first. Table set kind of sets up your table for you. Here we want to, on the table that we have on our board here, it's negative 2.5. So we could start at negative 2.5 if we wanted to. This tells us what we're going by. You could go by ones, you could go by 0.5s. It's already at 0.5, so I'd leave that. So I'm going to hit enter here. Enter again. Actually, we're going to go right to the table now. This kind of sets up where our table starts and ends at. So second and then table. And there it is, negative 2.5. You could fill in the graph over here if you wanted to and graph those points. Negative 3 points. I'll say 3.4 just to round it. Negative 1.5 is 0.875. That's our maximum, really close to our maximum. Actually was our maximum. At negative 1 it was 0. At negative 0.5 it's negative 1.87 roughly. And you could go right on down the list if you wanted to and then plot those points and you have your graph. But when you find the zeros, the maximum, minimums, and you kind of know your end behaviors, I think that's good enough for a graph anyway, for us. For the most part, the most important thing is being able to use your graphing calculator so you can see what the graph looks like, know what your end behaviors are, know where your zeros and maximums and minimums are. So I'm going to get rid of that. The only thing we really need here now that we haven't found is our end behaviors. Well, we did find them, but on here we're going to list them. As x approaches, you should have a little plus there, positive infinity. That's this side over here, the right-hand side. We know that it's going up. We decided that beforehand. F of x approaches positive infinity. And as x approaches negative infinity, the left-hand side over here, you can see that it's going down. As x approaches negative infinity, f of x also approaches negative infinity. So that's the first graph, that's the first half of the videos. I'll do another video to do the back of the sheet so you can see some more of this. But you go ahead and maybe try number 2 on your own and then watch the video. Maybe you'll learn from your mistakes, or maybe you got it done and understand it already. But peace out, Boy Scout.